GATE 2016 Civil Engineering Set 1 Question 27. The value of the integral 0 to infinity 1 by 1 plus x squared dx plus integral 0 to infinity sin x by x dx is. Four options have been given: A pi by 2, B pi, C 3 pi by 2 and D 1. The relevant NPTEL reference has been mentioned. So if we talk about the integration of dx by 1 plus x square, this would be tan inverse of x plus c. This is obtained by substituting x equals a tan theta. Similarly, if we want to integrate sin x by x dx from 0 to infinity, what we do is we use the Laplace transform technique. So we substitute limit s tending to 0 and multiply the function sin x by x with e power minus sx into dx. So essentially we are multiplying it with 1 because s tends to 0. So it does not make any difference in the integral. This would give limit s tending to 0. This is the definition of Laplace, so that would become Laplace of sin x over x. This can be further written as limit s tending to 0. This is fx and fx by x. So limit s tending to 0, it can be transformed to du by u square plus 1. So the Laplace of sin at is given by a square by t square plus a square. So using this rule, we have written du by u square plus 1 from 0 to infinity. This can be further written as limit s tending to 0. This is nothing but similar to dx by 1 plus x square, would give tan inverse of u from 0 to infinity, which would turn out to be tan inverse infinity minus tan inverse of 0, which would become pi by 2. So in this case we have been given two integrals. Let us call this as I1. So I1 is 0 to infinity dx by 1 plus x square. This can be written as tan inverse of x from 0 to infinity. Substituting the limits, tan inverse infinity minus tan inverse of 0. Tan inverse infinity is pi by 2 minus 0, which would give the value as pi by 2. For the integral I2, we can write it as tan inverse of x from 0 to infinity, which would be tan inverse infinity minus tan inverse 0, which is same as I1. This would give the value as pi by 2. This was obtained using the result in the previous slide. So I1 plus I2 can be written as pi by 2 plus pi by 2, which would give the overall integral as pi. So the value of the sum of the two integrals was obtained as pi, which is option B. The relevant NPTEL reference has been mentioned.